Hello everyone. So we will speak about winds loads. So here Eurocode. So we'll discuss how to calculate it, manual calculation and then automatic calculation. Here Eurocode in French language. So there is many factors to calculate the wind load. So what is more important is the dynamic pressure. So to calculate dynamic pressure we need the wind reference, and to calculate the wind reference we need many factors. So according to Eurocode, so we have reference value. It depends to many factor to the season, factor to the direction, factor to the reference wind. So the wind moyenne depend to the many factor. So it depends to the height of the building, and the height of the building depends to many factors too. So first factor, it is rugosity of the ground, and orographic in French language. And rugosity of ground depend to many factors too. So we have if the building close to the sea, if the close to the water pool, if in the agriculture zone, or if in the city zone. So we have here, if the zone 15%, there is a building with an higher than 15 meters. So here we have Toronto wind too, and in the end we got dynamic pressure. So dynamic pressure with this equation is depend to many factors. So dynamic pressure, we have interior and exterior. So we have here interior and exterior, and interior and exterior they are negative or positive. It depends the sign of the forces. So if there is pressure, there is positive. If there is suction, there is negative. So, and here we have to determine CS and CD. So C coefficient structure section 6 here. So we can determine it by here. We have many shape of building. We have determined it too. So here we have in many time exterior, the coefficient exterior and anterior. It can be 1. We have, it can be 10. So here if we have wall and the dimension of wall it's 2 times the length of the wall. So we have many type of forces, and these forces will augment if the wall is higher than and here we have the side wall is divided by zone. every zone has amount of pressure and coefficient. So zone I, it is multiplied by 1.2. So zone 2 multiplied by, and it's depend to the dimension between H and D. So all that we want to bring in consideration, and according to the pressure here, so the zone D, we can determine the coefficient in the roof. So we have many type of roof. We have a roof with one inclusion, so one size. The division of the roof is different, so as we see later here, so we can see it. So this coefficient will multiply with the dynamic pressure. So we have here 10, we have 1. We have different type of the angle, because the roof is not always the same angle. We have 5, we have 15, 13, 65, 75. Here we have with 2 inclusion. Be sure we have different zone. We can see here the zone here is not the same to the zone here. And then we have the table with many coefficients, and it the coefficient depend to the type of the angle. So we have 0, we have 90, and here we find another type of roof. We have different zone for distribution the effort and the force, wind force. If we have many roof, we have coefficient of reduction to the roof. So we had to reduction here 40%, here 20%, here we bring the load as here. Here we have another type of roof. So here, if I have here all that we speak about pressure exterior. Here anterior, how to determine the pressure anterior inside the building, the pressure inside the building. So here they speak about the if we have an overture, if we have open zone, we have for example window in the wall. So we have to calculate the surface of the window in the wall, and we realize what's the percentage of this surface according to the surface global of the wall. And with this number we can choose how we can define the pressure anterior according to the pressure exterior. So here they speak if I have a wall which has a surface of open surface is 2 times the other wall, so I can bring this value. If more than, I can bring this value. So here I have isolated roof. So this roof, it's in this term. So I have another coefficient to apply. So you can see the zone is not the same. So we have 2 type of it's punctual forces. we can apply the two type of forces. So we have punctual forces and we have surface forces. So here we have truss structure. So how we can apply the forces if we have a truss structure. So in this force, in this term, so all of that we can see. And here there is annex. There is site, this site, arrow code for example, for the wind. So we can determine in this building in which region. So, and we can determine category of the zone of building. So you can see here they explain different zone, and we can choose the location of our building. Here they speak about height of building, about this, about the ground. So this two coefficient is always 1. So here 1, 2, it's case 1, case 2. So we have in the end 60 Newton per meter per square meter. So this calculate automatically the coefficient, dynamic coefficient, dynamic pressure. So in Robo, here in Robo, we can define the wind forces automatically. So wind forces here generate, as we can see. So it's an advanced simulation. So here I choose wind pressure. I choose here. So I choose wind pressure 75 decanewton. So here it's not all. Here I can object. So I can, if I an opening in the wall, in the panel, then I can close it. So here I suppose there is a concrete wall, here the same way. If not, I can tell him to take all the element. So I can here for it wind wall, it's like this. I will let here in this shape 1 1. So I can do a start, for example. So the machine can see here the concentration of the wind force here is in which direction, in this direction. So we have here a big pressure about this panel, this grating. We have about 90 decanewton per square meter. So distribution of the effort. So it's finished to calculate wind. So we can see so the action of the forces. So the same way if we see the loads, so it is wind here, loads. So it's all for today. So to the next video.